All right, ladies and gentlemen, this is where we ended up, and this was the picture of our gas chromatography unit that we have in our laboratory that you will actually use. Yes, I'm going to say that again. You will actually use this piece of equipment. Can you believe it? Now, if you go through a university or a four-year program, you probably will never use a gas chromatography instrument because they don't really let you use anything at all. They are mainly textbook and they are mainly read the material, study the theory, and regurgitate it on a sheet of paper. And they will not let you use pieces of equipment like this. We're different. We give you the training that you need to use pieces of instrumentation, and you get to inject the sample. You get to run the sample. You get to analyze the sample using the computer software, and you get to process your own data. Now, you find me a four-year school or university that will allow you to do this yourself, and there's going to be very few and far between that will allow you to go into a lab and do this like we do in our program. So again, we're very unique in what we do, and I hope that if you're thinking about laboratory sciences or chemistry, that you really consider our program at Cape Fear Community College, because this is the training that you are going to be able to do, and this is the training that we provide. Okay, so this is the Shimatsu GC 2010 system. However, this is the GC system back 60 years ago, right? And the instrument looks a lot different back then than it does today. So first off, you see kind of these old knobs and analog scales that are basically here along the front of the machine. It looks like maybe this is a report printout with some paperwork coming off, a small little button press or a small keyboard over here to the side. It looks like she's at ease operating the piece of equipment because maybe she's got her cup of coffee that's right here, or maybe depending on the day that she's had, maybe it's a little more than coffee. Maybe it's Kahlua mixed in as well. And then here along the back wall, you see some gas tanks. So this is gas chromatography. It works by gas. Samples have to become a gas, and we need a gas in order to run it. And these are the gas tanks that are probably needed to run the GC units that are located in this laboratory. Now, feminist, brace yourself, because I'm getting ready to tell you something that you probably will not like to hear. And 60 years ago, when gas chromatography first came out, what you very um, uh, saw on a regular basis is a woman using the instrumentation. And the reason that they decide to use women back in that time is to let you know that if a woman can do it, anyone can do it. Yeah, now that's not the attitude that we have today, right? That's not the attitude or the perception that we have on women in today's generation, and at least I hope not. But back 60 years ago, very often, whenever these pictures were taken in front of instrumentation, they chose to use a woman in order to do that, for the most part, to let you know that this is not something that's scary, that you should not be afraid to touch. This is something that's very easily operated. It's something that anyone can do, and to prove that anyone can do it, we'll put a woman in front of it. So again, I hate to say that, but that was the fact of life, and that's how things were. All right, so here's another picture of a GC unit. This one, they actually used a man in the picture, but this GC unit is a floor model. There's two different floor models here. They're huge and they're big, right? So this is not what GC looks like today. I mean, you compare this picture to this picture. This is a countertop. It's the size of a computer, basically, that's right beside of it, a computer monitor. So going from something like this 60 years ago, or like this one 60 years ago, and something that's more condensed, a little bit more streamlined, a little bit user-friendly, and now we get instrumentation that looks very similar to that in a laboratory. But back in the day, you can kind of see some people maybe were afraid to use the GC instruments just simply due to their size and how massive they were, right? Not only that, but when gas chromatography first came around, this was the equipment that was introduced to the laboratory. And not everyone had training on pieces of equipment that looked like this. And because of that, people were very hesitant to learn how to use it and how to operate it. But the only thing that you have to do is just ask. No one is going to mind showing you how to use a piece of equipment in a laboratory. So, if you have a teacher in high school and you're one of our competition participants, tell your teacher, if you want to learn more about gas chromatography, come to campus with you. We'll get them to inject samples too. They can see how this machine works and they can see how to process data. It's not a problem at all. All right. So here is the birther of gas chromatography, and his name is Archer John Porter Martin. Born 1910 and passed away in 2002. So I would say this is pretty recent, 2002. English chemist, Nobel Prize in chemistry. He started off with partition chromatography, and this is the type of chromatography that gas chromatography builds itself upon. Now, Dr. Martin really specialized in vitamin chemistry. He looked at vitamin E and vitamin B2, and this was during the World War series, right? So we were very interested in the nutritional content of food that was pre-packaged for our warriors and our fighters to go out into the battlefield. And we wanted to know, did the vitamin content break down any at all throughout the processing and the storage of these types of foodstuffs? And Dr. Archer Martin comes into the picture and develops this technique to analyze a couple of important vitamins, vitamin E and vitamin B2, just to name a few, to monitor any changes that would happen. Martin was also featured on The Simpsons, Season 3, Episode 10, where Lisa brings him to the classroom and Dr. Martin introduces a gas chromatography for the classroom that Lisa's in. So you can imagine a bunch of middle school students or early high school students seeing a scientist like this that Lisa's so proud and excited to show. I've put a link into the PowerPoint presentation that will be shared with each of you, and this link is actually the obituary in the New York Times for Dr. Martin. So you're more than welcome to read it. It talks a little bit about his successes throughout his life as a scientist and the birth and creation of the gas chromatography field due to him. Right? So the first GC system was published in 1952. So, we're getting a little bit older. And again, over to the side, what do you see? We see a gas chromatography system, and there's a woman in the picture. So if it's easy enough for a woman, it's easy enough for you. So, again, hate to say it, but that was the attitude back in the day. Easy to construct, and the GC field grew quickly. So once people started to learn how to make and use the instrument, more and more laboratories wanted them in their laboratory spaces. Two major versions of the GC began to get made, however. There's always a thing with making it better. So there's two versions of GC. The first version uses what we call a packed column, P-A-C-K-E-D, and the second version uses a capillary column. These really go to the type of column that's used inside of the instrument. In the early stages of gas chromatography, it was packed that was used over and over and over. And there was a reason. And that reason is because the capillary version had a copyright protection, or a patent protection, sorry, a patent on the capillary column. And that patent prevented other people from making that column and trying to sell the column. So because of that, capillary was just put on the back burner. And then finally, in about the 1980s, the patent expired, and capillary quickly became the better option in the laboratory. And now the capillary is the most common form of the column that you will find in a GC system. All right, so if you're ever given that question, which one of these is the most common type of column in the GC system, it is now the capillary column that we use the most often. Today, capillary is used for a number of different industries. We're looking at pharmaceutical, we're looking at environmental, we're looking at cosmetic, we're looking at forensics. Any really laboratory that has a need for gas chromatography will use a capillary column now instead. We no longer even buy packed columns anymore. If you want to know the difference between the two types of columns, these will be discussed a little bit later, but here's a picture of a packed column and a capillary column. So this is how they were made back in the day. This is a packed column. It's a little bit thicker, stainless steel tubing most of the time, and they're very short. These are the columns that were used up until the 1980s. Then in the 1980s, the internals of the GC changed, and they changed over into what we call a capillary column, and here's the capillary column. So the capillary column is not stainless steel. This is typically made out of glass, and these are not short. They're very long. They go anywhere from 30 meter to 100 meters long. So these types of columns do a very good job separating more complex mixtures than a packed column does. Okay? All right. So this is where this video is going to stop. We now maybe have a little bit of history of the GC system and some of the changes that it goes through. And in the next video, we'll talk about some of the uses of the GC and maybe a little bit of story behind what some call the worst disaster in American history.